Hi, this is Tanya Chew. In this video, I'm going to focus on Cambridge IGCSE Physics Paper 4 Theory Extended Paper, May-June 2025, Paper 42. What are we waiting? Let us get started. Question number 1. Fig 1.1 is a speed time graph for an ice skater. Describe the motion of a skater between 0 and 3 seconds. Now, let me show you where is 0 and where is 3 seconds first. This is 0 second and this is 2. So this is 3 seconds because one small box represents 0.2 second. So 3 second, I am going to use the ruler. Okay, I'm going to use the ruler. Okay, draw up straight so that you can see it. Okay, this is 3. Here, this is the 3. Keep my ruler and I'm going to show you. Oh, from 0 second to 3 second, this is the motion that you're supposed to describe. Whenever, I give you a little bit of tip here, whenever the question asks you to describe the motion, you can either describe the speed of the object or the skater, in this case, or the acceleration of the skater. In this case, let us look at the graph. Oh, this is a speed time graph. Now, take the value of the speed. You can see that this is 10 and 12 different by 2, and then you divide by 10, so 0.2. This is 11. Now, the question only asks us to describe the motion, how the skater is moving. So I am going to say that the skater travels at constant speed of 11 meters per second if you want to be more accurate. Now, B, calculate the distance traveled by the skater between t equal to 0 and t equal to 3 seconds. You see, when a graph is being given, you just need to bear this in mind. There are 2 information that you could obtain from the graph. One is the gradient of the graph. The other one is the area under the graph. In this case, since this is a speed time graph, the area under the graph represents the total distance traveled by the skater. And the gradient of the graph represents the acceleration. Since the question asks us to find the distance traveled by the skater, so I'm going to use distance is equal to area under graph. This is the area of rectangular, so it is length times height. The length is 3, the height is 11. So the answer is as easy as 33 meter. So 33 meter is the answer. Now, the next one, C part 1, state what is meant by deceleration. So if you don't know, no worries with that. Do you still recall the definition of acceleration? It is the rate of change of velocity. So deceleration means the decrease in the rate of change of velocity. That's all about deceleration. Second part, draw a tangent to the graph at t equal to 9 seconds and use the tangent to calculate deceleration of a skater at t equal to 9 seconds. Remember, when the question stated that you have to calculate the deceleration, your answer, your calculation, right, shows the answer to be negative. Now, grade tangent. Oh, because at 9 seconds, which is here, okay, the graph is a curved graph. So a curved graph, to determine the tangent of the gradient of the curve, you have to draw tangent. Tangent is a straight line that passes through the point. So I have to draw a tangent which passes through my 9 seconds. So let me draw it right now. Okay, adjust a little bit. Okay, make sure that it passes through that 9 seconds. Only focus on your 9 seconds. I think I think should be it. So I'm going to just draw it. I draw longer tangent line. And I'll keep my ruler first. So that's my tangent. So I better label it. This is my tangent. And you have to calculate deceleration. Remember just now I told you, I said that gradient of the graph represents acceleration. So your gradient, you need to get a negative to show that the skater is decelerating. Now I have to get 2 points here. Let me show you which points I want to use. Okay, I might want to use this one. I check the coordinate first. This is 11.2, x-axis is 11.2, x coordinate. And the y coordinate should be 0.2. So 0.2 here, and then the other coordinate. Okay, let me see which one is the easier one. I might want to use this. Okay, so this point here on the x-axis represents 2, and on the y-axis, this is 6.2. So I got my 2 coordinates, so I'm going to determine the gradient of the tangent, right? Gradient of tangent represents deceleration. So get the 2 points, the 2 coordinates that I got was 2, 6.2, and 11.2, 0.2. Y2 minus Y1 first. So 6.2 minus 0.2. 0.2 over x2 minus x1. 2 minus 11.2. Get an answer? 6.2 minus 0.2 divided by 2 minus 11.2. And my answer is negative 0.65 meter per second square. Now, you have to show that you get this negative value because this negative value represents, this negative sign represents deceleration. But when you write down your answer, because the negative sign represents deceleration, so you just need to key in the value. 0.65 meter per second square. 2 significant figures. And let me tell you the range given by the mark scheme is within 0.5 to 0.7 meter per second square. So mine is still within the range. Now, question number 2. Fig 2.1 shows a balanced uniform meter ruler made of wood. The width of the meter ruler is 2.6 times 10 to the power negative 2 meter, and the thickness of the ruler is 6 times 10 to the power negative 3 meter. Define, first part A, define moment of a force in words. So you have to use words, no formula. So I would say moment is being defined as the product of force and perpendicular distance from pivot. And I'm done. B, on Fig 2.1, mark the position of the center of gravity of the meter ruler with a point labeled X. Label the distance X from the 0 cm end of the ruler. So the 0 cm is here. Okay, how do you know where is the center of gravity? And what is center of gravity? Center of gravity is a point where the whole weight of the meter ruler is acting. And I want you to check for this key point here, right? This is the hint given to you, uniform meter ruler. When the question mentioned that this ruler is uniform, the center of gravity will act exactly at the center of the meter ruler. So since the meter ruler is 100 cm length, it will act at 50 cm mark. So 50 cm mark is maybe somewhere over here, a bit over than the pivot. So this is 50 cm mark. So draw. Do I need to label X? Yeah, I'll just label X. So I'll put here X. So 50 cm, this is X. And you have to label the distance x. Okay, so I'm going to label it from x to the 0 mark. This distance is 50 cm. And I'm done with that. Now, and the next one, C.1, show that the mass of the meter ruler is 0.081 kilogram. Since the weight of a meter ruler is not shown here, I need to draw it out. This is the weight of my meter ruler. And this is a pivot involved here. And the first part of the question, they ask you to define the moment. So it has something to do with the moment. Right, look for the second hint here. The second hint is exactly at this first sentence itself. Show a balance. So when this system or this uniform meter ruler is balanced, it means that the principle of moment must be obeyed. What is the principle of moment stated? Principle of moment states that the total anti-clockwise moment must equal to the total clockwise moment in order for the system to be in equilibrium. Now, first step, identify your pivot. Oh, pivot is here. Second step, you have to identify all the forces that are acting on the system. I have 0.34 acting downwards. I have the weight of the meter ruler acting downwards. And I also have 0.12 Newton acting downwards. Only 3 forces involved here. Second step, identify the direction of moment caused by all these forces. First one, we look at 0.34 Newton first. Look at the direction of the force. It is downwards. When it is downwards, to determine the direction, the easiest way is that while it is going downward, it has to turn towards the pivot. After all, this force causes a turning effect. Remember? Turn towards the pivot. Since the pivot is on the right-hand side, so it has to turn in that direction. This is called anti-clockwise direction. Weight of the meter ruler going downwards as well, but pivot is on the left hand side. While going down, it has to turn towards the pivot. This is called clockwise direction. 0.12 Newton, which is beside the weight of the meter rule, it is acting downwards and the pivot is on the left hand side, so it has to go down and add towards the left. This is called clockwise moment. Once we have determined the direction of moment, things will be easier. So just write down total clockwise moment. Total clockwise moment must be equal to total anti-clockwise moment. Clockwise moment. Total clockwise moment, I have W, which is the force, multiplies by perpendicular distance from the pivot. Since X is at 50 cm mark, and the pivot is at 42 cm mark, you just take 50 cm minus 42 cm, and you get 8 cm. I'm not going to change that to meter. It doesn't matter because all the distances are measured in cm. So I'm going to just leave it like that. And then plus with 0.12 cm, 0.12 Newton multiplies by perpendicular distance, 80 minus 42. So you take 80 minus 42 and you get 38 cm. So I'm going to write down 38. And total anti-clockwise, there's only one force, which is 0.34 Newton. Multiplies by perpendicular distance from the pivot, you take 42 minus 10. 42 minus 10, you shall get 32. And work it out. So W is equal to 0.34 multiplies by 32 minus 0.12 multiplies by 38 divided by 8. You should get 0.79 Newton. Hold on, this is not the end of the answer because you have to show that the mass of the meter ruler is 0.081 kilogram. This is just a weight. But what's the relationship between mass and weight? Weight is equal to mass multiplies by gravitational acceleration. Weight is 0.79. Mass multiplies by gravitational acceleration, which is 9.8. Therefore, the mass is equal to 0.79 divided by 9.8. And I got 0.081 0.0806 kilogram. I round it off to 0.081 kilogram, and I'm done. Second part, calculate the density of the wood of the meter ruler. To calculate density, first of all, you need to recall the equation of the density, which is equal to mass over volume. Mass is 0.081. Volume. Volume, this is a meter rule, so the volume would be the width times the thickness and the length of the meter rule. But the length of the meter rule is in cm. So I'm going to change it to meter because my width is in meter and the thickness of the ruler is also in meter. So I'm going to change that. I am going to take the length, 100 cm, change to meter is 1 meter, times the width, which is 2.6 times 10 to the power negative 2. 2.6 times 10 to the power negative 2 times the thickness, which is 6 times 10 to the power negative 3 to get the volume. And finally, I end up getting 519 or 520 kilogram per meter cube. You can round it off to 520. 520 kilogram per meter cube. Done. Now, the next one, define momentum. Momentum is as easy as the product of mass and velocity. That's the definition of momentum. And B, Fig 3.1 shows two toy trains, A and B, on a track. Mass of train A is 0.45 kilogram. Okay, I better write here 0.45 kilogram, and mass of B is 0.21 kilogram. The trains do not have motors. Train A travels towards B and they collide. Immediately before the collision, the velocity of A is 0.34 meter per second to the right. Wow, I guess correctly. And velocity of B is 0.12 meter per second to the left. The trains stick together when they collide. When you see the word stick together, you definitely know that this is inelastic collision. Only inelastic collision that make the trains stick together. Calculate the velocity of the train immediately after the collision. For this type of question, look at the marks given, 4 marks. That means it is not easy. To solve this type of question, you have to use the principle of conservation of momentum. States that the total momentum of the trains before the collision must be equal to the total momentum after collision. So total momentum before, and another thing that you should bear in mind is that momentum is a vector quantity. And I want you to see this. Train A is moving to the right, train B is moving to the left. So you have to set one direction positive and the other direction to be negative. I am going to put direction to the right as positive, direction to the left as negative. If I end up getting a negative value, because after the collision, I don't know whether the two trains are moving to the left or to the right, but I would know it when I do my calculation. If I get a negative value, it means that my trains are moving to the left. If I get a positive value, it also means that my two trains are moving to the right. Right. Now, since I already determined the direction of my train, so momentum, mass of A, 0.45 multiplies by initial velocity of A, 0.34. 0.45 multiplies by 0.34 plus mass of B, 0.21, multiplies by velocity, initial velocity of B, which is negative 0.12. So 0.21 multiplies by negative 0.12, which is equal to inelastic collision, meaning to say that the two trains stick together. So the total, you just add up their total masses, 0.45 plus 0.21, and you multiply by the final velocity. And here, I got 0.153 minus 0.0252 equals to 0.66 V. And here I got 0.1278 equal to 0.66 V. V, make V as a subject. This is equal to 0.194 meter per second or 0.19 meter per second. And I got a positive value. So positive value meaning to say that the train is moving to the right. Direction is to the right. If you get a negative value, it means that the train is moving to the left. Now, see, a different train is traveling with a momentum of 0.26 kilogram meter per second. The train slows down and stops after 2.1 seconds. Calculate the average force acting on the train during this time. So average force is the rate of change of momentum. Change in momentum divided by time. Change in momentum has to be final momentum minus initial momentum per time taken. That is F. Therefore, my F, this is a momentum given, right? That is the initial momentum, mu, and mv slow down and stop. mv is equal to 0. So 0 minus 0.26 divided by 2.1. So I get negative 0.124 Newton. So average force, whether you put a negative value or you don't put a negative value, it would not affect because the force, there's only one force acting on this train. So I'm going to ignore my negative value, Newton. Number 4, A, Fig 4.1 shows two metal containers, A and B. Container A has a dull black outer surface and container B has a shiny white outer surface. A and B both contain very hot water at time t equals to 0. Temperature of the water in each container is recorded every minute. First part, state which container has a larger temperature change over the first 5 minutes. Explain your answer. The answer is actually container A. I want to state first. That's my 1 mark over there. And I have to explain why. First of all, black surface and black and dull surface. Black itself is a good absorber of heat, and at the same time, it is a good emitter of heat. It absorbs a lot of heat, but it could also reflect a lot of heat. Okay, so I'm going to write that down. Black surface is a good conductor and a good emitter of heat. Right? So a lot of heat, a large amount of heat is being absorbed by container A, and also a large amount of heat being emitted to the surrounding. That causes a larger temperature change over the first 5 minutes. Now, the second part, after 30 minutes, the temperature of the water in container A remains constant state in terms of energy transfer. Why temperature remains constant? First of all, temperature is constant, meaning to say that there is no more heat transfer. Heat can only transfer when there is temperature difference between two substances. Right, so I would say that there is no net, or you say resultant, heat or thermal energy transfer between container A and surrounding. Third part, the experiment is repeated without the lids on the container. So I open up, right? And the surface of the water in container A and B are exposed to the surrounding air particles. State the name of the additional method of the energy transfer that occur, right? So the energy additional method is that because some of the water will be, right, evaporated to be changing state to become gas state, so it will cause the hotter, right, gas molecules to move outwards and be replaced by the colder air molecules. So this method is called convection. Now B, Fig 4.2 shows the metal pan with a wooden handle. Explain why there is much greater rate of transfer of energy through the metal than through the wood. First of all, metal is a good conductor of heat, whether you agree. Metal is a good conductor of heat, and metal itself contains free electrons, or you can say delocalized electrons. Okay, whereas I compare between the two first before I explain. Whereas wood is an insulator and has no free electrons. That's the difference between metal and wood. Now, so I explain in terms of the heat transfer. When heat is being absorbed, okay, so atoms in metal vibrates and transfer the heat. Transfer the heat to neighboring particles. And at the same time, because due to the free electrons, at the same time, free electrons gain kinetic energy and drive, or you can say move faster to transfer the heat to the whole metal. That's it. Now, number 5A, describe an experiment to determine the speed of sound in air. State the apparatus required, the measurements taken, and how to calculate the speed of sound in air from the measurements. I need to highlight some important terms here. Right, so we have to follow whatever is being asked by the question. Experiment, determine the speed of the sound. You have to state apparatus, measurements taken, how to calculate the speed of the sound in air from the measurement. You may draw a labeled diagram as part of your answer. If the question mentioned that you may draw a labeled diagram, I would strongly suggest you to draw a diagram so that you can describe your experiment in a more detailed manner and more accurate. Yeah, more accurate manner. So this is a ground. I'm going to draw this. And then, okay, don't worry. Okay, done. Get my ruler first. Okay, and I have two students actually. Student A, hello. Okay, this is okay, I'm not good in drawing. I'm going to label it later. This is student B. Ooh, okay, this is B. And then this is, okay, it looks longer. It looks like a meter rule, but it's actually not a meter rule because meter rule is too short. The distance measured by the meter rule maximum is only 100 cm. I don't want that. I want longer distances. So I'm going to use, okay, once you draw a diagram, you have to label your diagram. So this is called measuring tape. And then this is called my pistol. Student A is holding a pistol, not a real gun, so you don't have to worry. Right, so I have done with my labeled diagram. I am going to answer the question. Apparatus required. Apparatus, okay, required. I need a measuring tape. Measuring tape. I need a stopwatch. These are called apparatus. And after that, measurement. So this is my methods. So I said that distance between, or I just put a symbol for distance first because it is easier that way. I want to show how to calculate the speed by using the symbol later. Distance, which is D, between student A And student B is measured by measuring tape. Now the second method, once you measure the distance, student A fires pistol, student B starts stopwatch at the same time. And then method 3, I say that the student B stops stopwatch when sound of pistol is heard. You hear the sound, stop the stopwatch. And then after that, okay, speed of sound can be calculated by distance between two students divided by time taken, measured by the stopwatch. Done. B, Bluetooth is used to connect mobile or cell phone to your headphones. First part, state the name of the region of the electromagnetic spectrum used by Bluetooth. Bluetooth, we normally use radio wave so that it can cover more, it can go longer because the radio wave has the longest wavelength, but some of the Bluetooth is using microwave as well. Now, the second part, state the speed of the electromagnetic waves in air. Speed of the electromagnetic wave. Electromagnetic wave, in fact, all the electromagnetic waves travel with the speed of light in air and in vacuum. So it is 3.0 times 10 to the power of 8 meter per second. Done. And the third part, the frequency of a Bluetooth network is 2.48 gigahertz. Calculate the wavelength of the waves used in Bluetooth network. So just use the wave speed equation, V equal to F lambda. Lambda is equal to V over F. Lambda represents wavelength. Since this is a Bluetooth, right? We use radio wave which travel with the speed of light divided by frequency. 2.48 giga is one of the prefixes, which is 10 to the power of 9. And then you will get 0.12 meter. So 0.12 meter is the wavelength. Now, number 6, A, fig 6.1 is a full-size diagram of a lens and an image eye of an object. So my advice is, if you want to print out this paper, make sure that you set, okay, do some setting on your printer. Print full size. Print full size. Then only you will get your answer accurately. Now, the focal length of the lens is 3 meter. You have on fig 6.1 mark 2 points with labels F to show the position of the principal focuses of the lens. So I have measured. They mentioned that focal length. Focal length is the distance measured from the center of the lens. This is the center of the lens. You measure 3 cm. So this is my focal point or the principal focuses. Now, on fig 6.1, you have to draw 2 rays from the image to locate the object. Draw the object and label it O. Okay, this is the image. So I'm going to draw the object. Okay, I'm using blue color. First of all, remember, whether you draw from the image to object or object to the image, the difference is just the arrow of the ray. First one, any ray that is parallel to the principal axis would be refracted towards principal focus. So I'm going to refract towards the principal focus. Okay, this is my, okay. I draw it digitally, so it might not be that very accurate as compared to you draw on a piece of, on the paper. So I try my best. So this is it. I draw longer because I don't know where the object is. And the second ray, I'll draw the arrow later. Second ray any ray that pass through the center of the lens will just go straight. So this is it. The intersection between the two rays that you draw will show you the location of the object. And remember, object you have to put O, right? And then the ray must be coming from object to the image. So arrows must be drawn correctly. Now, the third part. The object is moved so that it is 6 cm to the left. State one characteristics of the image formed when the object is in this position. So the object is moved even further, 6 cm, right? So I would say that the one characteristics of the image is that the image is still inverted. That's all. B, fig 6.2 shows a simplified diagram of an eye with rays from a near object. The eye needs correction for long-sightedness. On fig 6.2, draw the path of the rays inside the eye to show the effect of the long-sightedness. Long-sightedness is because the object is formed at the back of the retina. So you have to draw that. No correction yet. Okay, so you just use this. The easiest one, you draw the center ray first because the center ray would just go through straight. One. Okay, just draw this one straight. Okay, I'm just going to draw it straight here. And then, okay, after that, you might want to draw this one a bit. Follow this ray before enter the lens. Okay. Okay, this is the lens of the eye. Okay, let me draw it nicely. Okay, center of the lens. So you determine yourself. Okay, if you want it to be more accurate, you determine the center of the lens so that it is easier. And then, okay, this is also same thing. Okay, ray going towards the center of the lens. Here, center of the lens. And then ray will be refracted. Okay, just draw refraction occur. Okay, like that. Refracted. Okay. So I'm going to draw it. Here. The other one, I'm going to draw it as well. So that they will meet at a point. Just draw it so that they meet at one point. Okay. And keep my ruler first. Right. And then you have to show that where the rays are going. So this is where the image is being formed. At the back of the retina. So the second part, a lens is used to correct the long-sightedness. Thank goodness there's a lens. And draw a lens suitable for this correction. As long as you draw converging lens, you are correct. Diverging lens is to correct short-sightedness. This is number 7. Number 7A, state what is meant by electric field. Electric field is a region in which electric charge experiences a force. B, a plastic rod is rubbed with a cloth. The plastic rod becomes negatively charged and the cloth becomes positively charged. And you have to explain why. Remember, when you learn about electric charge, there are two charges altogether. One is positive charge, the other one is the negative charge. And bear in mind, only negative charges can move. So this rod becomes negatively charged. It is because this plastic rod gains electrons. And the cloth becomes positively charged because the cloth is losing electrons to the plastic rod. I'm going to explain in that, okay? I'm going to use a better term to explain it right now. Due to rubbing, rubbing causes friction between two materials. Electrons from cloth flow or migrate to plastic rod. Cloth is losing electrons and rod is gaining electrons. That is why rod now has more electrons. It becomes negatively charged. And cloth now is losing electrons. It has lack of electrons. That is why it becomes positively charged. The second part, negatively charged plastic rod is suspended in an insulating thread. Another negatively charged plastic rod is brought close to the suspended rod. State what happens to the suspended plastic rod, right? So negative and negative, they're like charges, so there will be repulsive force. State what happens to the suspended plastic rod. It will move away or repel away, right? Due to repulsive force between like charges. Now define, see part 1, define the kilowatt hour, kWh in words. So kilowatt hour, right, power times time is this actually energy, electrical energy transferred when power of 1 kilowatt used in time 1 hour. That's it. The second part, a small lamp illuminates an electric oven. The lamp has an output power of 25 watt and operates for 220 hours in 1 year. PD across the lamp is 230 volt. First part, calculate the energy transferred by the lamp in 1 year and give your answer in kilowatt hour. So still remember, energy is equal to power times time, or power is equal to energy over time. So make energy as a subject. Power is given as 25 watt. The time is 220 hours in 1 year. So just time 220 in 1 year. So your answer is 5,500 watt hour. So you have to put in kilowatt. So you divide by 1,000. So you basically get 5.5 kilowatt hour. So the answer is 5.5. Calculate the current in the lamp. Current in the lamp, I'm going to use power is equal to IV. Power is given, which is 25. Current, I don't know, but the PD across the lamp is 230. I is equal to 25 divided by 230. Therefore, your current is 0.11 ampere. 0.11 ampere is the answer. Now, let us move on to question number 8a. Fig 8.1 shows a simplified diagram of an AC generator. First part, state the names of the components P and Q. P and Q, oh, you look at P and Q. So remember, AC generator, we use slip rings. There are 2 rings. And then X and Y are called carbon brushes. Carbon brushes is to connect between the slip ring brushes. Add a circuit completer to add any output. Could be lamp, could be resistor, etc. Now, second part, explain why an electromotive force, EMF, is only induced when the coil is turning. So I will explain even more. I'm going to use short form. EMF can only be induced. Remember, yeah? EMF or current can only be induced when there is a change. When there is a change in magnetic field, right? This can only be occurred when magnetic field is cut by turning coil. That's it. And third, state one possible change that causes a larger EMF to be induced. So you might want to, because the coil is turning, if you want it easy, increase the speed. Increase the turning speed of the coil. Turning speed of coil. Or you can say increase the speed of rotation is not a problem. Next one, B, Fit 8.2 shows a circuit diagram. Resistor A, B, C, and D are identical. The current in resistor A is 2.4, so I'm going to write down 2.4 ampere. The first one, state the value of the current in resistor B and explain your answer. I would say the current in resistor B because these resistors are identical. So if A is 10 ohm, B and C will be 10 ohm. But B and C are connected in series. So in series, that means the resistance, the total resistance of B and C is definitely higher than the resistance of A. Since the resistance of A only take 2.4 ampere, resistance due to the resistance, combined resistance of B and C, the current that flows through B and C would be decreased by half. So I say 1.2 ampere. My explanation is that because the total resistance of B and C is equal to double the resistance of A. Since the resistors are connected in parallel, EMF or PD flows through B and C and A. Okay, PD across B and C and A, okay, is the same. Double the resistance causes current, okay, current reduce, okay, by half. Done. And the second part, calculate the value of the current I. Why? Okay, this one, I know that this is 1.2 ampere. This one, D, there's only one resistor, so it would take 2.4 ampere. I is the total current that flows out from the cell. So I is equal to I across A plus I across BC plus I across D. I is equal to I across A is 2.4 ampere, I across B and C is 1.2 ampere, and I across D is 2.4 ampere. So the total I is 6.0 ampere. So 6.0 ampere is the answer. And then after that, the third part, calculate the reading on the voltmeter is 5 volt. Calculate the resistance of resistor A. 5 volt, that means EMF is also 5. You can use Ohm's law, V equals to IR. R is equal to V over I. So since I know this is 5 volt and the current across A is 2.4, so I take 5 divided by 2.4, I get 2.1 ohm. 2.1 ohm is the answer. Question number 9A, part 1, state what is meant by background radiation. You know, nowadays it is very hard to stay 100% healthy, right? 100% clean air because there are so many buildings that give out radiation, right? Our detectors are not selective. So our detector, one, it is switched on, so it would detect the stray radiation from the surrounding. Could be the food that we consume, could be water that we drink, could be coming out from the building that we stay in, right? What is meant by background radiation? Background radiation means unwanted, okay, stray or random radiation detected by detector. And the second part, state one source that makes a significant contribution to the background radiation. Maybe building, maybe rocks, buildings, rocks, or the food that you consume. B, radioactive isotopes are used in some medical treatment. Radium-223 is an isotope of radium. Radium-223 decays by the emission of alpha particles to an isotope of radon. Complete, the first part, complete the nuclide notation equation for this decay. So I know alpha. Alpha is a helium nucleus, so the nuclear number is 4, proton number is 2. So all I need to do now is to balance to find the nucleon number of radon. So you take 223 minus 4, you will get 219 because nucleon number must be balanced, proton number must be balanced as well. So you take 88 minus 2, you will get 86 here. Second part, radium-223 is injected into the body to treat a specific organ. Explain why the source must be inside the body. You know, this is alpha. It will give alpha particles. An alpha particle is a big particle. It has the lowest penetrating power. If you inject outside the body, it might not getting into your body. So that is why the source must be injected inside the body. So I'm going to explain, right? To avoid, okay? Because, okay, you might want to say because alpha particles will be, okay, stop by skin. Maybe your skin will stop it from penetrating into your body. C, an isotope of technetium is injected into the body to detect cancer in one of the organs. The half-life of the isotope is 6 hours and it decays by emitting gamma radiation. The radiation is detected outside the body. First part, explain why a source of gamma radiation is used. First of all, gamma radiation is being used because gamma has the strongest penetrating power. And then it can penetrate through most of the stuff, and it is not easy to stop by the organs or tissue or muscle in your body. So when it is coming out from your body, it can still be detected by detector. So I would say that, okay, because gamma radiation has the strongest penetrating power. Gamma radiation can be detected when it comes out from the body. That's it. Explain the second part, C second part, explain why a source with a short half-life must be used. Because gamma radiation is a radioactive, so it will cause the dose to, because you don't want it to stay too long in your body because it could cause harm. Right, so that is why I said that short half-life, it is just enough to show the result of diagnosis, but not too long to stay in your body. It will bring more harm. After all, it is radiation, radioactive substances, right? So that it does not, okay, stay too long in the body. Just nice to give the result of the diagnosis. Okay, now 10A. Table 10.1 shows data for planets A, B, C, and D. First part, state and explain which one of these planets is closest to the sun. Now, closest to the sun, the surface temperature must be the hottest. So the hottest one is B, 623. So I will say which planet? Planet B. Okay, the surface, explanation, the surface temperature is the highest. That means it is very close to the sun. It will get most heat from the sun. Now, the second part, calculate the surface temperature of planet D in degree Celsius. So this surface temperature in Kelvin is 93 Kelvin. If you want to convert to degree Celsius, you have to minus 273. So you will get negative 180 degrees Celsius. Negative 180. Negative must be included. And the third part, an object falls through a height of 2 meters on each of the planets in table 10.1. State and explain on which planet the object falls 2 meters in the shortest time. Ignore any effect due to atmosphere. I would say that shortest time is A. Why? Because A has the strongest gravitational field strength, so it would drag down the object very fast, right? So A, planet A, okay, planet A has the strongest gravitational field strength. Hence, okay, it has strongest gravitational force acting on object. Gravitational force is a force that tried to pull the object down. Now, B, Fig 10.1 shows some of the stages in the life cycle of a massive star, big star. First one, the massive star starts to expand to form red supergiant, a big star. And after that, expansion causes the red supergiant to explode. We call it a supernova, give out a lot of heat, a lot of light here. And, okay, it gives out nebula, which contains, because this is a massive star. So nebula that gives out, that contains heavy elements, the elements which are heavier than iron in your periodic table. And after that, leaves behind, depending on how massive the star is. If the star is just a massive star, it will form neutron star. If the star is super duper massive and super duper large, it will collapse, yeah, to itself and then to form a black hole. Done. And the second part state the quantity that the brightness of a supernova in the galaxy can be used to determine. So we can use the brightness to determine the distance between galaxy, it is galaxy, between the distance of the galaxy and Earth. And that's all for our discussion, yeah, for this paper. I hope that you will, if you have any hesitation, if you face that, any doubts in my explanation, you need further, more detailed explanation, feel free to comment below. And thank you very much for watching. See you again in my next video. Bye.